In this video, I'm going to cover 4 different problems and 5 different strategies for tackling linear systems of equations. We're going to go through substitution, elimination, graphing, making a table, and plugging in. This question says, if xy is the solution to the system of equations above, what is the value of x? There's a lot of ways you could do this. I'm going to do elimination. So I'm just going to multiply the first equation by 2. That will get my x terms to cancel. So that gives me negative 6x plus 8y equals 40. Then I'm just going to rewrite the second equation here. 6x plus 3y equals 15. Then you're just adding straight down. That gets your x terms to cancel. This is 11y equals 55, making y 5. Usually the thing that's easy to solve for is not what they're asking for, which is true here. So now you're just going to plug in. I'm going to plug into the second equation because it looks less annoying. So 3 times 5 equals 15. So it looks like x is going to be 0 because I have 6x plus 15 equals 15. And at that point, I would just know that it's 0. But if you want to write it all out, you would get 6x equals 0. So the answer is 0. If you wanted to double check, you could plug that into this one. It would give you negative 3 times 0 is 0, plus 4 times 5 is 20. Yes, it checks out. So you know you got it right. Next, this one says, according to the system of equations above, what is the value of x? You could solve this multiple ways. I'll show you 2 different ways you could do it. So first, I'm just going to do elimination. So I'm just going to subtract the second equation from the first one. It's going to be a little ugly, but I just did that as a shortcut because it's already there. Okay, so your x terms cancel. You get negative y equals positive 16, which means y is negative 16. They want x, which is very typical that they want the number that's harder to solve for. So let's just plug into one of our original equations. So x minus 16 equals negative 9. Now we're just solving for x through inverse operations. And this gives us that x is 7, which is the right answer. If you want to double check, you could plug into either equation. 7 minus 16 is negative 9. Yes. Now I'll show you how to solve this with substitution. So you could isolate y here. You could express y as negative 9 minus x. That's a good thing because you're trying to solve for x, so you want everything in terms of x, and then you're going to sub in the value that you just got for y into the second equation. So now you have x plus 2 big parentheses here, negative 9 minus x equals negative 25. Now you're just distributing, combining like terms, solving through inverse operations. So you have x minus 18 minus 2x equals negative 25. We're going to add 18 on each side. And then that gives us negative x equals negative 7. X equals 7 is the right answer. And you could check it like you did last time. For this question, there's many ways you can solve it. I'm going to show you 2 ways to solve it. The first way is algebraic. So it says the graph of a line in the xy plane has slope 2 and contains the point 1, 8. So let's plug that information into y equals mx plus b to solve for b. We're given that the slope is 2, and then we have that point 1, 8, which is an x and a y that we can sub in here. This will let us solve for b. So we're just subtracting 2, subtracting 2. We get that 6 is the b value for the first equation. So that first equation is going to be y equals 2x plus 6. And then we're going to get the equation for the other line and set them equal to each other. So the first one, I'll write up here, y equals 2x plus 6. For the next one, if you had the slope formula programmed in your calculator, which is highly recommended, then it would be really easy. You would just type the points in. If you didn't have it, you would have to know the slope formula. So that is just going to be change in y over change in x, which means y2 minus y1 over x2 minus x1. It's going to give us negative 1 over 1. So the slope for our second line is negative 1. We're going to have to plug in to y equals mx plus b to solve for the b value. Just like we did before, we're going to plug in a point. So we have a point 1 comma 2. We're going to plug that in. 2 equals -1 times 1 plus b. This is 2 equals -1 plus b. And then add 1 on each side. So 3 is your b term. So now we can fill that in up here. And then I am going to make some room for us here. So we are going to set those equations equal to each other. And then we're just going to solve for x. They want something rather unusual. They want the x and the y coordinate added to each other. So we're going to set these equal to each other. 2x plus 6 equals -1x plus 3. And then we're just solving for x. There's lots of ways you could do this. I'm just doing one way. So 3x plus 6 equals 3 minus 6 minus 6. This gives us 3x equals -3. So x equals -1. And then we just have to plug it into one of the equations. I'm going to plug it into this one. So y equals 2 times -1 plus 6. That tells us that the y is 4 when the x is -1, meaning our answer for the point where they intersect is -1 comma 4. But then remember, they want us to add the x and the y value. So the last step here is to add -1 plus 4, which gives you your answer of 3. There are so many ways you could do this problem. I'll show you another way you could do it. Here's another way you could solve that question once you find the equation of the line for the first equation. So we found that that was 2x plus 6. Then we can just plot our points for the second line because they told us these 2 points. And then we can just follow the general trend of this line. So we can see that the slope is -1 because to get from our green point here, 2 comma 1 to our blue point here, 1 comma 2, we're going up 1, left 1, which is -1 for the slope. So let's just keep doing that and see when we intersect this red line. So up 1, back 1, up 1, back 1, and then we're there, right there. The point is -1 comma 4. That is the point of intersection. And then remember, they wanted you to add the x and the y. So that would just give you -1 plus 4 is 3. Another way you could solve this question is by creating a table of values. So for the first line, which I'm indicating in red here, we know that the slope is 2, and we know that it contains the point 1 comma 8. So we can fill that in our chart. We have the point 1 comma 8, and then our slope is 2, meaning that as our y value increases by 2, our x value is going to increase by 1 because it's change in y over change in x is +2 over +1. So this is going to be 12, this is going to be 3, and then it works backwards also. So if we subtract 2 for our y value, then we're going to subtract 1 for our x value. So now we've just generated a table of values for the first line. Let's see what would happen for the second line. So we know that when x is 1, the y output for the second line is 2. And then we also know that when the x input is 2, that the y output is 1. So from this, we can determine the slope of this line. So this slope, the change in y, is -1, and the change in x is +1. So that means our slope is just -1 over 1, and then we can use that to fill in values in the table. So this will be easy for this part here. So that would go down by 1. These are going to be going up by 1. And what you're looking for is you're looking for a repeated value. So we have that. So if we look here, when x is -1, the y outputs are the same for the 2 lines. So that means that that is our point of intersection. So our point of intersection is -1 comma 4. You could also use your actual calculator to graph the 2 equations and look at the point of intersection, or you could hit second table, and it's going to give you a table just like the table we showed in the last explanation. This question could be solved with elimination or substitution, but I'm going to use it to show you how you could plug in the answer choices. If you ever have repeated answer choices, you might want to start with those. I will just do that, even though I know that those are not the right answer. So let's do that. Okay. So we're just going to plug in x is 4, y is -6. And it's easy to do it in the first one because you can just write it in above it. So you'd have 3 times 4 plus 4 times -6. And you're just going to figure out what that would be. It would be 12 minus 24. So it's definitely not right. So it's already out. The right answer is B. Let's just show that. So it really doesn't take all that long. So we're going to do 3 times 3 plus 4 times -8 and check out if it equals -23. It does. It's 9 minus 32, which is -23. Now we want to check it in the second equation. We want to be careful that we're plugging in correctly. So it's 3 comma -8, and we're plugging in. That would be 2 times your y value is -8 minus 3. Does it equal -19? It does, because 2 times -8 right here is -16 minus 3 is -19, so it works. Plugging in can work. As you saw, it was pretty quick. Even if I had tried one of the other values, I could have quickly figured out that B is the right answer. This has been your refresher on 5 strategies for solving systems of equations. Let me know if you want more examples of any certain type of question, or if there's any other videos I can make to help you out on your SAT, ACT, or in your middle school or high school math classes.